Okay, example 3, we're going with the same directions, graph, 2 periods of each function. Okay, and we're going to start by looking at y equals the sine of x minus pi over 4. Okay, so the amplitude of this function is 1. Okay, the period is 2 pi. Okay, but we have this phase shift in here, right? So that means that our graph is shifting to the right, pi over 4 units. Okay, so normally we've been graphing, right, and starting at the x or the origin, right, and we've been going from 0 to 2 pi and then going in the opposite direction, 0 to negative 2 pi. Okay, that is going to change. So I don't have a vertical translation, which is nice. That means the x-axis is my midline. Okay, my amplitude is 1. That means I'm going to be 1 unit above the midline and 1 unit below the midline. Okay, however, instead of starting at 0, okay, we're shifting pi over 4 units to the right. So that means that our graph would then start at pi over 4. And if you want to figure that out algebraically, you can take what's inside the parentheses, your phase shift, okay, and solve this algebraically. And that gives me my starting point. Okay, my ending point, instead of ending at 2 pi, I'm going pi over 4 units to the right. Okay, so I'm taking 2 pi and I'm adding pi over 4. Okay, so I would say if you want to figure this out algebraically, you can take, again, your phase shift, what's inside the parentheses, and set it equal to your period, which is 2 pi. Okay, or logically, you can just add pi over 4 to 2 pi. Okay, so 2 pi plus pi over 4. So I've got 8 pi over 4 plus pi over 4 equals 9 pi over 4. Okay, so one period of my graph, if I start at pi over 4, is going to end at 9 pi over 4. Okay, and now I need to figure out the rest of my critical points. Okay, so my first critical point that I'm going to choose, and this is, I mean, pi, or the graph of sine goes on negative infinity to positive infinity. So I'm just picking like this one little period to graph, okay? I could start this wherever I want, I could end it wherever I want, but just so that it's easier, I'm picking pi over 4. Okay. Each of those intervals, right, if I want to figure out the interval between my critical points, I take my period and I divide by 4. So that gives me pi over 2. Okay, so if my first critical point, I'm going to do this up here. Okay, the point I chose to start at is pi over 4. Okay, to get my second one, I'm going to add pi over 2. Okay, and if I get common denominators here, that's going to be, let's see, 4 pi, or 2 pi over 4. Okay. Okay, so I have pi over 4 plus 2 pi over 4 is 3 pi over 4. So my second critical point is 3 pi over 4. Okay, then to find my next one, 3 pi over 4, okay, plus 2 pi over 4, right? Because that's pi over 2, but with common denominators, 2 pi over 4, that's 5 pi over 4. Okay, and then I take 5 pi over 4, again, plus 2 pi over 4, which is 7 pi over 4. Okay, so there is the first period of my graph, right? The first cycle. Okay, with sine, I start at the midline, I go up to the max, back to the midline, down to the min, back to the midline. Okay, so there's one full cycle of that graph. Okay, but I need to do 2 periods. Okay, so you could continue on adding pi over 2 for another period. I'm going to go in the negative direction. Okay, so I would then take pi over 4 and I would subtract pi over 2, which is the same thing as subtracting 2 pi over 4. So that's negative pi over 4. Okay, so my next critical point would be, sorry. Okay. And this next one would be negative 3 pi over 4. If I keep okay, negative 5 pi over 4 and negative 7 pi over 4. Okay, so if I finish this cycle, I go back to the minimum, midline, max, midline. Okay, and there is that graph. Okay, now let's look at y equals negative 3 cosine of 2x plus 5. Okay, so I'm going to write this in standard form like we did yesterday by factoring out a 2. Okay, so it looks like this. My amplitude is 3. My period is 2 pi over 2, okay, which is pi. That means the distance between my critical points is going to be pi over 4. Okay, so instead of starting at 0, okay, I have a vertical translation, right? We're moving to the left, pi over 2. So instead of starting at 0, I'm going to start at negative pi over 2. And instead of ending at pi, like I normally would, right, if we went from 0 to pi, I've got to move that pi over 2 units to the left. Okay, so x equals pi minus pi over 2. That's the same thing as 2 pi over 2, which is pi over 2. Okay, so I'm going to go from negative pi over 2 to pi over 2. That's going to be one cycle. Okay, and so I'm going to lay out these critical points here. I probably should have done that before I did this, but I'm going to start at negative pi over 2. Okay, the interval between my critical points is pi over 4, so I'm going to take negative pi over 2 plus pi over 4. Okay, and I need common denominators, so I have negative 2 pi over 4 plus pi over 4, okay, is negative pi over 4. Okay, then I'm going to take negative pi over 4 plus pi over 4. Okay, that equals 0. Then 0 plus pi over 4 Okay, and pi over 4 plus pi over 4 is 2 pi over 4, which is pi over 2. Okay, so those are the critical points in that first period. Okay, my amplitude is 3. I don't have a vertical translation, so I'm 3 units above and 3 units below. Okay, so when I'm graphing cosine, I start at the max, but I have this negative sign. So I start at the min, midline, max, midline, min. Okay, so there is one period. Okay, if I want to graph a second period, I'm going to continue subtracting negative pi over 4 to get these points. So this would be negative 3 pi over 4. Okay, negative 1, negative 5 pi over 4, and then negative 3 pi over 2 would be this last one. Okay, and I would continue on graphing, just like that.